This video is a part of our lesson 6.5, and we're focusing on the absolute value of a complex number. So what's in the yellow box is the rule to find the absolute value of a complex number. So refer back to a complex number, z equals a plus bi. Remember, this is your real axis distance, and this is your imaginary axis distance. So if we look at this graph, this would be your A distance, and that would be your B distance of your real and imaginary axes. For an absolute value of that complex number is you're going to square the A value, square the B value, add them up, and then square root it. And what you're going to get is this distance. This is the distance that the complex number z is sitting out here is from the origin. That's what you're finding, is that distance or the absolute value. So here's an example. Example 2. Find the absolute value of the complex number. So our complex number is 3 plus 4i. So let's graph it first. So this is your real axis distance, that's your A value. And then plus 4i, this is your imaginary axis distance, which is your B value. So let's graph it. So we're going to go 3 to the right, and then 4 up, finishing right there. So there is our complex number z, which is 3 plus 4i. So again, to graph it, you go 3 to the right, and then 4 up. And what we're going to do is we're going to find the absolute value. So we're going to find out what that distance is. What's the absolute value of z? So we're going to use our rule on the previous slide in the yellow box. Right here. So the absolute value of z is we're going to square root and then square our A value and square our B value, add them up, and then square root it. So here's our A value. We substitute it in to our equation, so 3 squared. Our B value is a positive 4, so 4 squared. Simplify those numbers. So 3 squared is 9, 4 squared is 16. Combine those terms together. Square root of 25, which is 5. So the absolute value of z is 5. So what this distance from here to there is a distance of 5 units. That's what we just found.